heat waves, drought, tornadoes, hurricanes, floods, blizzards, bitter cold. Extreme weather has an incredible impact on people across the globe. On Mount Washington, our scientists brave some of the worst weather on the planet to improve our understanding of our warming world.
All right, good evening, everyone, and welcome to Mount Washington Observatory Science in the Mountains lecture series hosted by Mount Washington Observatory. And I'm Brian Fitzgerald. I'm the Director of Education here at Mount Washington Observatory and here to tell us all about the successes and challenges of hurricane forecasting is Senior Hurricane Specialist John Cangialosi. Thanks so much for joining. If you're already familiar, the Mount Washington Observatory is a nonprofit member-supported organization with a mission to advance the understanding of the forces that create Earth's weather and climate. And we accomplish that through a few different ways by operating our Summit Weather Station with around-the-clock weather observation and forecasting, by conducting research and product testing projects, and by developing and offering innovative educational programs. If you have some questions for tonight's speaker and you're joining us through Zoom, don't forget that you can add a question at any time throughout the program. We will leave time at the end for a Q&A session. Just make sure you use the Q&A button that you find at the bottom of your toolbar there. If you're joining us on Facebook, thanks so much for joining us through there. We won't be able to respond to your questions in real time, but we'll do our best to respond after the program this evening. If you'd like to join us for a future program on Zoom, don't forget to register over at mountwashington.org/SITM. Alrighty, well, thanks again, everyone, for joining. Before we get going with tonight's program, I will launch a quick poll for you. We got some great trivia questions coming to you from our speaker and a couple from myself as well. If you're joining on Zoom, you'll see a poll that's just popped up on your screen, and we'd certainly welcome your participation. First question, we're always curious where you're joining from this evening, whether it's a state within New England, perhaps outside New England, or even outside the US of A. Love to know where you're joining from tonight. Another question, with Saturday coming up here, it is the observatory's largest annual fundraiser of the year, Seek the Peak. We're curious if you yourself are participating this year in Seek the Peak, or perhaps you're supporting someone who is this year. And then we have a few trivia questions from our speaker, John. The first question being, what hurricane hazard has been the deadliest in the United States? Rain, wind, storm surge, or tornadoes? Next, what month is the peak of hurricane season? Is it July, August, September, or October? And then lastly, how many Category 5 hurricanes have hit the US in history? I'll give everyone just a few more moments here to select your responses. Looks like quite a few of you have already participated, so we'll just give it a few more seconds here. Thanks so much for participating. Love to get your minds warmed up for tonight's program. Thanks so much for doing that, and we'll end it in just 3, 2, 1. All righty, looks like we got some good participation there. We'll share some results with everyone. Looks like Massachusetts and New Hampshire, certainly the two big leaders. And in fact, Massachusetts winning tonight's poll, 33% of you joining from Massachusetts, and quite a few of you from outside the region as well. And one individual from outside the US of A. Thanks so much for joining. Curious, for those of you who are participating in our fundraiser this week, the Seek the Peak Hike-a-thon and Outdoor Expo, 10% of you are participating or supporting someone who is. The rest of you, no. Oh, what a shame. It's a good time. And since it is such an important source of funding for the observatory, we do welcome you learning more about the program, supporting hikers and other people who are raising funds for the observatory. You can learn more about that over at seekthepeak.org. And if you're looking for someone to support, you can always search Brian Fitzgerald as someone to support, just throwing that out there. Alrighty, and then for our poll questions for tonight, what hurricane hazard has been the deadliest in the US? More than half of you said storm surge. We'll have to check in on that one. What month is the peak hurricane season? 3/4 of you saying September. And then maybe a little bit of a split here. How many Category 5 hurricanes have hit the US in history? Most of you thought around 6, or maybe 4, or maybe it was 2, or maybe it was 8. I don't know. We'll find out in just a moment here. So without further ado, I would love to welcome our speaker for this evening, John Cangialosi. John, hey, can you hear me and see me okay?
Hey, Brian. Yeah, I can hear you and see you just fine. Hopefully you can hear me okay, and I'm turning my video on right now.
Awesome. Yeah, I can hear you. Hey, I can see you too. Well, John, thanks so much for joining tonight, joining all the way from the great state of Florida, all the way down south, many hundreds, more than 1,000 miles at least away. But thanks so much for making the virtual journey anyways. And we'd love to hear all about your program this evening.
Yeah, no, my pleasure, Brian. And I wish I could be in New England this time of year and escape the constant 90-degree heat and humidity, but I'll live just curiously through all of you.
Sounds good.
All right. So, Brian, would you like me to take it from here?
By all means, yeah. Feel free to share your screen again there, and I will disappear into the background here if you need anything.
Okay, appreciate it, Brian, and thanks for listening in, everybody. As Brian mentioned, my name is John Cangialosi. I'm one of the senior hurricane specialists at the National Hurricane Center, which is located in Miami. And what I'm going to talk to you about today is to really talk about hurricanes, their history, how we do some forecasting at the Hurricane Center, talk a little bit about their hazards, and even a little bit about what we think is going to happen this hurricane season in 2022. So I hope you find this interesting, and I will say that I'm pretty impressed by the poll answers. They were pretty much right. We're going to actually answer all of them through this presentation. So we'll hit on those as we get to those topics. All right, so let's get started. So first I want to tell you where the National Hurricane Center is, give you a little view of what our building and facility looks like and exactly what we do there. So we're located, as I mentioned, in Miami, Florida. It says we're the same location since 1995, but the Hurricane Center has been in Miami forever, essentially. It's been bouncing around different locations. And you might say, why would you put the National Hurricane Center where you have meteorologists that have to forecast hurricanes very much in harm's way? And I would say that's a really good question. Initially, when the Hurricane Center started in the 1950s, it made a lot of sense to put the Hurricane Center in a place to sort of really be connected with the community that had very high risk of hurricanes. Today, it makes a lot less sense, but nonetheless, we are still there. Now, the facility you see here is located about 10 miles west of downtown Miami.
Oh, hey, John, sorry to interrupt, but we're not seeing your slides at the moment.
Oh, no. Okay,
let's must have bumped yourself out of share screen mode.
Oh, let's fix that. I'm sorry, Brian.
That's all right.
So I'm gonna try that again. Yeah, it did bump us out. So let's give it another try. And thanks for interjecting.
Yeah, no, you got it.
Okay, I'm gonna hide that. I must have hit some sort of button. All right. Hopefully, Brian, does that look all right now?
You got it. Awesome. Thank you.
All right, great. Now, I want to tell you a little bit about the facility. If anyone's been to Florida, you know that we essentially have no hills. And one of the things that's interesting is that a lot of us live in these called evacuation zones where we're worried that the ocean water could get to where we live. This facility is considered to be on a ridge, and that's 6 feet above sea level. So that's considered to be on a hill. Now, that the design team of the building included the name here, Herb Saffer. I don't know if anyone actually knows that name. In South Florida, it's very well known. He's an engineer that helped design the hurricane wind scale. So this facility is expected to withstand any hurricane, and we never evacuate it. So if a hurricane is coming to South Florida, I don't care if it's a category 3, 4, or 5, we are staying in that facility. And it has been tested since the mid-90s and has held up just fine. All right, so I'm going to talk a little bit about what the Hurricane Center does. I don't want to get into too many details, but I'm curious what exactly you all know from the Hurricane Center. I put some pictures on the right, and what the Hurricane Center is really known for is this graphics that really depict where the storms are going and exactly what we're trying to predict. But in a nutshell, we have what's called advisory packages that are issued every 6 hours when we have a tropical system, which includes where the storm is going, how strong it might become, how big it might be, and any hazard information that we'll talk about, like storm surge or rainfall or how much wind or rip currents along the beaches. And we even have some more technical discussions to try to really illustrate what the risk may be to the population of where it's going. One of the coolest things for me working at the Hurricane Center is its international presence. We are no means US centric. The National Hurricane Center covers a really large area. So if the system, a tropical system, is anywhere from the west coast of Africa and the west coast of Europe, all the way across the Atlantic Basin to the United States or Mexico, and then even into the Pacific Ocean to about 2/3 of the way to Hawaii, that is the National Hurricane Center's area of responsibility. In a nutshell, it's huge. So it's really never a quiet day during hurricane season, simply because of the large real estate area that we cover. All right, so what do we think is going to happen in 2022? So the Hurricane Center and the Climate Prediction Center within Noaa focus on a long-term view by season. And here's the prediction for this season: a 65% chance of an above normal year, a 25% chance of a near normal year, and a little tiny sliver of hope of a below normal season. Now, I know in New England, you may pay a little less attention to hurricanes, but it has been really busy lately. I'm going to show you some statistics about how busy. But ever since about 2016, just about every year has been running busier than normal. Here are the predicted ranges. We're expecting 14 to 21 named storms, that's tropical storms or stronger, of which we think 6 to 10 could be a hurricane and 3 to 6 could be major hurricanes. Major hurricanes are serious news. That's where we have category 3s, 4s, and 5s. That's the definition of a major hurricane. So a busy year. Now, part of the reason we think it's going to be busy is because of the continuation of a phenomena in the Pacific Ocean called La Nina. I'm not sure you ever heard of that, but this, believe it or not, occurs along the equator in the Pacific, where the water temperatures basically change their distribution. And believe it or not, if you perturb what's happening in the Pacific Ocean, you get a different answer thousands of miles away in the Atlantic, where the waters tend to be warmer and the wind shear tends to be lower, and that combination leads to more storms, or at least the potential for more storms. All right, first I want to talk a little bit about climatology. Now, what's illustrated here is every single tropical cyclone, and by the way, a tropical cyclone is a more scientific term that includes weak systems like tropical depressions, moderate systems like tropical storms, and stronger systems like hurricanes, but they have to be tropical. They can't be winter type storms. This includes everything we know of in history. Now, when I say history, for meteorology, that doesn't go back forever. That goes back to 1851. That's where hurricane records begin in the Atlantic Basin. In the Pacific, the records don't go back nearly as far, only to 1949. Now, I want you to sort of stare at this map for a minute. Each one of those red lines you see correspond to a track that a tropical cyclone has taken that we know of in history. Now, I want you to notice something. Just about anywhere you are in the Atlantic Basin, whether you're across the Caribbean or in the Gulf of Mexico or near the Bahamas or just way north. Let's say, what if you're near New England? Or what if you're even north of New England in Atlantic Canada? Guess what? History shows us that those areas experience hurricanes. And you might say, how is this possible? How could we get hurricanes in Canada? This doesn't make a lot of sense. After all, hurricanes are tropical systems, right? They need water temperatures that are at least 80 degrees. Well, you can blame just about all of that on the Gulf Stream current. That spreads warm water from the Florida coast and near the Bahamas northward toward New England. And in fact, the Canadians in Halifax have their own hurricane center. That is because they get hit by hurricanes. Now, contrast that with what's happening here in the Pacific. Try to locate Southern California right in here. Almost no hurricanes. Almost no hurricanes in history have affected Southern California. Much lower latitudes than places like New England or Atlantic Canada. That's because of the cold current that streams southward from Alaska, and there's chilly waters being trajected all the way far south, even as far south as the northern Baja Peninsula of Mexico. So when hurricanes try to make their way up toward California, they quickly die out because of those cool waters. So all I really want you to get from this is that the ocean currents are really dominating where hurricanes go. They are the number one factor in determining your vulnerability in different parts of the country and different parts of the world. All right. Now, one of the quiz questions we had up front were, how many Category 5 hurricanes have hit the US? Some of you got this right. So how many? I saw 2, 4, 6, and 8. That's the options I gave you. The number one answer was 6. The number two answer was 4. The correct answer is 4. Yeah, only 4. And remember, that goes back to 1851. So here's my question. Where were those 4 most powerful hurricanes, these Category 5s that struck the United States just 5 days before they made landfall? Where were they located? Well, take a look. The Labor Day hurricane, Camille, and Michael did not exist 5 days before their landfall. Andrew was located out here in the central Atlantic. All right, how about 3 days before landfall? Where were they then? Well, here's the Labor Day hurricane. The Labor Day hurricane struck the middle Florida Keys in 1935. And check this out. Went from a weak tropical storm with maximum winds of 40 miles an hour to a Category 5 hurricane in 1.5 days. It kept that intensity all the way here into the Bahamas, and then rapidly intensified and struck Isla Mirada here in the middle Florida Keys. Try to get down there one day, especially if you like to fish, but it was devastated in the mid-30s. And there was a railroad at the time being constructed to connect Miami to Key West, and that railroad system was destroyed and then never rebuilt after that hurricane came through. What about Camille? This was in 1969. At this point, it was only a tropical storm, maximum winds of 65 miles an hour, just 3 days before it struck Mississippi and Louisiana as a Category 5 hurricane. How about Andrew? This one definitely is close to heart for us here in South Florida. This was a tropical storm, only 50-mile-an-hour winds, just 3 days before it struck extreme South Florida, even south of Miami, and really changed history there forever, honestly. I mean, things were almost never rebuilt for years after Andrew came through in the early 1990s. And then lastly, and most recently, Hurricane Michael was also a tropical storm in the Northwest Caribbean, 50-mile-an-hour winds, just 3 days before it made its catastrophic landfall right here in the Florida Panhandle. And by the way, that was only in 2018. The only saving grace for Michael was it hit a relatively low population area in this state, but still was very devastating and a fair amount of loss of life as well. So the point is, just before we had these Category 5 hurricanes, they were only tropical storms, just a few days before they made their landfall. All right, another quiz question we had up front was, what is the busiest month of the year in hurricanes and hurricane season? And if you look at this sort of campfire looking graphic, you'll notice that it's a very, very well-defined peak. Now, whether you look at the yellow area shaded in here, which is just for hurricanes, or the red shading here, which is hurricanes and tropical storms together, you would basically get the same answer. That the climatological peak in the season occurs in the middle of September. In fact, it's right on September 12th. The funny thing is, and I often say this, is that's actually my wife's birthday, September 12th. And we've been together a long time. Actually, we talked about this the other day. It was more than 20 years. And she still doesn't understand that I'm almost never going to be off on her birthday because it's actually right at the climatological peak. Now, hurricane season is formally defined as half the year, June 1 to November 30th. But the real meat of the season, the real activity is in just 3 of those months, August, September, and October. So here we are. Today is, today is July 12th. We have not yet had a hurricane in the Atlantic so far this season. That is not unusual because, again, as you'll see in this campfire graphic, we're right about here in this graphic. The real season has not yet begun. The real season is right in this framework here. So we're just about to ramp up and get busy. Climatology is a pretty good metric for these things. All right, let me talk a little bit about how we predict hurricanes at the Hurricane Center. And I just want to talk about this kind of casually with you. And I'd love to hear any questions you have toward the end, so I promise to save some time. All right, so track forecasting. The first element when we make a hurricane forecast is, well, where's it going to go, right? You know, at the Hurricane Center, we make a 5-day forecast. So we're trying to figure out where it's going to go from now to 5 days from now. In fact, we've been experimenting for years now to try to make that forecast go out further to 7 days. And I think we're going to be successful of that. And that probably will become a public product in the next few years. Now, believe it or not, track forecasting, figuring out where the storm is going to go, is the easiest part of the forecast. The simple analogy I have for you is this cork and stream analogy right here. So imagine for a second this. Imagine for a second that you're kind of hovering over a stream and you throw a cork in that stream. You can pretty much predict where that cork's going to go, right? It's going to move within the current. Now, you might not get all the wiggles and wobbles just right. You might not get the timing exactly right, but you're going to get the theme right. That's where we are with hurricane forecasting in terms of track. We can get the theme right, predicting exactly where it's going to make landfall, predicting exactly when it's going to make landfall. That's beyond the scope of our abilities, but we've improved a lot. And to show you how much we improved, let me just show you the stats right here. Now, I think I mentioned at the beginning that the National Hurricane Center really came aligned with the Noaa in the 1950s. But we didn't start making systematic routine forecasts until the 1960s. And I have basically all of our statistics shown here in this one chart for track prediction. So in the 1960s, the average error from the Hurricane Center, we went out to 3 days, so 72 hours. The average error is on this purple line. And for day 3, it was more than 400 nautical miles, or if you want that in regular miles, about 450 regular stat sheet miles. In the 1970s, you'll see the errors dropped a little bit. They dropped a little bit more in the 80s, but the real improvements in our abilities of predicting track started really in the 1990s, where the errors dropped nicely. And as you can see, that trend has not stopped. It's continued through the 2000s, the 2010s, and even so far into the 2020s. So this is tremendous improvements, ones we're really proud of. Now, even though this looks awesome, I still want you to know that there's still error today. I mean, we're so much better than we were decades ago, but we're nowhere near perfect. And the average error today at day 5 is not too far from about 200 miles. So there's still uncertainty in every single prediction. But we do have to take a minute to acknowledge the success. Now, to show you this another way, let me sort of repackage up that same data. Let's imagine for a second that it's 1990 and the Hurricane Center forecast is forecasting a hurricane landfall right there where I drew that yellow square, which is near Biloxi, Mississippi. The average error in 1990 for a forecast like that is shown by that blue circle. So you could interpret it this way. We're predicting it to be making landfall near Biloxi, but it could come out here closer to Houston, or it could actually make landfall out here in this Big Bend region of Florida. But today, if we repeat the same exact forecast, the average error looks like that red circle. So really huge gains. And the important point here is that when we lower down the error like this, we can narrow in the warning area, we can narrow down the evacuation area, and really save ourselves a lot of cost. And maybe even more importantly than the cost, we can communicate more accurately with the public and reduce the amount of false alarms. Because the biggest problem for me as a forecaster at the Hurricane Center is people always thinking that the Hurricane Center is wrong. I'm not going to evacuate next time. Nothing ever seems to happen. We don't want that mentality out there, because the time they choose not to evacuate is the time that maybe they really should have evacuated. So these narrowing errors, this improving prediction, is an excellent thing all the way around. Now, the improving prediction is, I'd like to say, really like a round of applause for the new forecasters and the people there. But in reality, how much has technology changed? Technology like we're using now didn't exist in the 1990s. technology has changed tremendously. And that improving technology is really what's helped us get most of these improvements. All right, so I mentioned this already, so I won't kind of beat the point. Forecasts are so much better, but they're not perfect. These are the average errors today. So the average 24-hour track error is around 35 nautical miles. That's about 40 regular miles. By day 5, it's 170 nautical miles. That's about 200 regular miles. So we often tell our users and emergency managers to sort of buffer in this uncertainty when looking at anything from the Hurricane Center, because the forecast will never be right on the money. We just can't be. It's an inexact science. All right, how about intensity forecasting? And what I mean by this is predicting the strength. Now, this is much harder. So part of the reason this is harder is because the intensity forecast really depends upon the track. So if you get the track wrong, the intensity forecast could be wrong simply because you thought the storm was going to be in a different place and perhaps in a different environment. Also know that the intensity forecasting is just more challenging because it's what we call a multi-scale problem, meaning it depends upon things that are large scale, like water temperatures or how much wind shear or how much moisture, but it also depends upon small scale things like where exactly the thunderstorms are located and how big is the storm and how symmetric is the storm. So understanding all of those elements are complicated. And unless you get all of those elements right, you're simply not going to get the intensity forecast right. So we're getting better at this, but I'll show you we still have a ways to go. So if you take a look at our predictions here, when you look back into the 1970s on the blue line, or the 80s on the green line, or the 90s on this orange line, or the 2000s on the red line, this is about 40 years of data with really not a lot of improvements. But the big improvements have started here in the 2010s and continued into the 2020s. So now we're finally starting to figure this out. In fact, I'll tell you a story. About, I don't know, 5 or 6 years ago, my boss asked me, hey, John, why do you think we made no improvements for like 4 decades and all of a sudden started making improvements? What really changed around 2010 to just sort of change the way our statistics look? And I told him at the time, I was like, I got 2 theories on that. And one theory I got is there was new models. Now, most of you probably have heard of weather models that you're listening. I'm sure if you're listening to this, you're interested in meteorology. And most of you probably have heard of weather models like the GFS or maybe the European. And those help us a lot for predicting track, but they don't help us at all for predicting intensity. In fact, they don't have any skill at predicting the storm's strength. But new models that are less known, like it's called the HWRF or the HMON. They're very strange acronyms that really no one seems to know outside of the tropical meteorology community. They're the ones that really led the way. And I told him at the time, I'm like, maybe we're finally seeing some bang for our buck from these new models. Multi-million-dollar projects were thrown at those models. And I remember him saying, well, okay, yeah, maybe. And then there was this sort of long pause. And then he said, well, do you have some sort of other theory? And I was like, well, yeah. I said, well, you hired me in 2010. There it is. I got there. We started getting better. Maybe that's the answer. And I remember him like looking at me in the eyes, and he didn't have a good sense of humor. And he was like, well, let's go with that model one. Maybe that one's right. All right. But even though the Hurricane Center is improving, just like for track, there's still errors today. And the simple thing for you to understand, let's say we're forecasting a storm to make landfall near Cape Cod, or let's say near Gray, Maine. The average intensity error is off by about a category. So if we're predicting it to be a Cat 1 in that region, it could be a tropical storm. It could be a Category 2. I mean, that's about our abilities. So I'd like to say we're better than that, but our statistics are basically showing you that that's about our abilities at the current time. And believe it or not, that's way better than we used to be, as I just showed you. Being off by a category isn't super impressive, but it's way better than being the 2 categories off that we used to be. All right, now we also forecast storm size. Now, I'll be honest with you, this is the most overlooked parameter when it comes to tropical systems. Everybody is so connected to saying, where is it going and how strong is it going to be? No one ever seems to ask me, well, how big do you think it's going to be? And you might think, well, okay, well, why does that matter? It matters a ton. Let me show you an example. In 2004, Southwest Florida got hit by Hurricane Charlie. Hurricane Charlie was a very powerful Category 4 hurricane at landfall, and it devastated portions of Southwest Florida. However, outside of a very small zone, Charlie's impacts weren't that severe. It generally looked like tornado damage because of its small size. And if you look at that red circle, that depicts the eye wall, or the region where the strongest winds existed. The very next year, almost the same area got hit by Hurricane Wilma in 2005. Now, Wilma was weaker. It was a Category 3 officially at landfall, but it was so much larger. And the extent of damage from Wilma was way more severe. In fact, even the financial losses were nearly double in Wilma than they were in Charlie. And that's because of the size. The size really is a huge factor to controlling the hazards, like storm surge, like wind, like how much rain. Size is so connected to that, but it's often severely overlooked. Now, one of the more challenging parts of my job personally is to put up hurricane watches or storm surge watches or warnings. Now, putting this up is a huge decision, especially doing it for a large metropolitan area, let's say like Miami or New Orleans or New York City. Putting up a hurricane warning calls into effect lots of emergency management, calls into effect evacuations in some circumstances. So we try to get this right. And more importantly than even getting it right, we try not to change it that much. We don't want to put New York City in a warning now and then take them out in 6 hours. Unlike other weather disasters, like tornadoes, for example, hurricanes are really long duration events. I often tell people if you like to cook, hurricanes are kind of like making chili. They take a while. You can think about it. Try to make the right decisions and set yourself up to make small changes going forward. Unlike tornadoes, we just don't have that kind of time. So when we put up a hurricane warning or a storm surge warning, we often think about how we're going to change the forecast in the future. We often think about the vulnerability of the area that could be affected. How long is it going to take to evacuate that area? And we often consider the time of day. We don't want to put a warning up at 10 p.m. at night or 11 p.m. at night, and some people don't get that message to the next morning. So we might change our decisions based upon all of these factors. And like I mentioned earlier, we do this internationally too. So even though we have direct responsibilities for putting up warnings in the United States, internationally, we're looked at as the experts on this side of the world. So we'll talk to countries like Bermuda, the Bahamas, Mexico, Caribbean islands, for example, even European countries, to help guide them in making their decisions. Now, we don't formally put up warnings for those countries. We are simply advisors for those countries, but we do help them along the way, and we're essentially there to help coordinate that message for them. Now, once our information is ready to be released and put out to the public, all of the elements of the forecast that I just spoke about, from there, we then focus on communication. Now, at the National Hurricane Center, the room you see here that I'm circling is our media room. It's a dedicated location for the media to actually come to our facility and talk directly to the forecasters and management at the center to help get the message out to national media in particular, like Fox or CNN, things like that. Here's some more pictures. We also do this through social media and do this in at least 2 languages, certainly in English and Spanish, and on occasion in French. Now, one of the things I want you to appreciate as the Hurricane Center, even though it's a national center, I wish I should have put this as a poll question. How many hurricane forecasters do you think the Hurricane Center has? Only 10. Only 10 hurricane forecasters. That's it. So we're doing this with a really small staff. Now, of course, we have support staff. We have a marine unit. We have public affairs people. But the meteorologists, the amount of meteorologists that are dedicated to this mission is really, really small. All right, so I did list this question as a poll question earlier, and I'm going to stop in about 10 or 15 minutes. So which hazard has the greatest potential for a large loss of life? I saw a lot of answers for B, rain-induced flooding, and I saw a lot of answers for D, storm surge. And I think D was the leading answer, and that is the right answer. So it is storm surge. Now, I want to show you what's published on this, and I want to talk about what's not published. So first, let's start with what's published. So the Hurricane Center did a study back in the mid-2010s, and we looked at how many storms occurred between 1963 and 2012, and just focused on the US. And in the US, calculating all the fatalities from these tropical systems, what was the specific hazard that led to those fatalities? Well, the number one hazard by a lot was storm surge, 49%. The number two hazard was rain, 27%. So your answers are right on the money, by the way. Then we had a whole bunch that were kind of basically similar severity. Surf, those are people that are actually in the water during a hurricane. Offshore causes, those are people that are on boats. Wind, wind, and tornadoes are a pretty small percentage. Now, when most people think of hurricanes, they think of wind. But in the reality, that's not what kills people. What kills people is water. In fact, 90% of the direct deaths we get in hurricanes come from people that drown. So the focus, when you think of a hurricane, the focus needs to be on water hazards, because history has showed us that that is the big factor. Now you might say, well, that study ended in 2012. Yeah, so what's happened since? Well, we're working on it. Since 2012, the number one fatality hazard has been rain. So your answers are essentially perfect. These two water hazards tend to flip-flop. And because storm surge has gone down, we've really limited storm surge fatalities in the last few hurricane seasons. We haven't been so fortunate with the rain-induced flooding. All right, so let's talk about these hazards: wind, waves, tornadoes, storm surge, inland flooding. Basically, the whole package of hazards are important when it comes to hurricanes. And one of the negatives, that really a communication negative on our part, is the Saffir-Simpson scale. Everyone wants to know what the category is. Every time I take a media call, or every time essentially I communicate on social media, how strong is the storm? What's its category? What's its category? Now, it's fine to communicate the categories when it's strong, like category 3, 4, and 5. I can get everybody to take these seriously. But what if it's a category 1? People tend to take that a lot less seriously. But the category only tells you what the strength of the wind is. We already talked about that wind isn't our biggest problem. Rain is our biggest problem. So focusing too much on the category is a detriment. It's a detriment to the hazards that we know are most deadly. So let's talk briefly about storm surge. This is the greatest potential for a large loss of life. And in Hurricane Sandy, if you were in New Jersey or in New York City or portions of Connecticut in particular, this was terrible. 73 deaths occurred from Sandy. $65 billion in damage occurred during that hurricane. And just about every single penny came from storm surge. Wind was not a huge factor. There were serious gusts, but you can get serious gusts in New York and New Jersey and portions of New England, as you all know, but you don't see storm surge like that. And Sandy was officially a category 1 hurricane. By the way, I know it gets titles of like a superstorm. There's no technical definition of a superstorm. The Noaa doesn't have a definition for that. That just really sounds kind of fancy. Sandy was a transitioning hurricane into a extratropical or winter storm. And what about Katrina in 2005? 1,200 deaths. 1,200 deaths from a hurricane? We didn't think this could happen in modern day stuff. We saw that in the 1900s, early 1900s, $108 billion in damage. Katrina is still the costliest hurricane in US history. Caused a maximum storm surge in Mississippi of 28 feet. 28 feet above ground. That was the maximum surge. Here, take a look. This is right about near ground zero for Katrina. Here's a house in Waveland, Mississippi. And this was taken before Katrina moved through. So watch the house, watch this live oak to the right of the house, and all of the green grass here in front of the house. Because as you probably can guess, it didn't look like that after Katrina moved through. Here's what it looked like after its passage. The live oak is still there, but just about everything else is gone. And the lawn is all burnt up due to saltwater penetration. Essentially, the ocean got there. Let's move on. What about rain? Rain-induced flooding is a big deal. Take a look at this. This is in Houston. This was the worst flooding event ever of a tropical cyclone in the US, and it occurred in 2017. The picture on the left is of an interstate running through Houston. Now, first, let's acknowledge an engineering flaw here. The interstate's in a ditch, right? I mean, you can kind of see this is all downslope, right? So the interstate's in a ditch. And in 2017, when Harvey moved through, they saw 40 to 50 inches of rain, and the interstate looked like that. Now, that is an entire year's worth of rain for Houston that fell in less than 1 week. So I'm not surprised that it looked like that. But certainly that engineering flaw didn't help things. What about closer to home for all of you? How about Irene in 2011? There was already saturated up in New England and upstate New York before Irene came through. And we got all this erosion. When this sort of canal and river outflowed, we got this road erosion that you see here, and significant mudslides and water damage that you see in upstate New York. Irene was much more consequential for upstate New York and western New England than it was for New York City, where it officially made landfall. And how about tornadoes? These are a big deal too. About 70% of hurricanes that make landfall produce at least one tornado. And about 40% produce 3 tornadoes or more. And sometimes you just get this tornadic outbreak that happens. And that's what happened in 2004 when Hurricane Ivan made landfall along the Gulf Coast. We had tornadoes that occurred in those red dots in that red circle in Florida and the extreme deep south here on September 15th. They spread across other portions of the southeast on the 16th, and then into the mid-Atlantic on the 17th. And we had 117 tornadoes. And a couple of years ago, Hurricane Isaias spread a whole bunch of tornadoes from Virginia up through New York and into Connecticut. So tornadoes are something we need to watch. Now, we know when tornadoes are going to happen, and you will too. If you're going to be in this quadrant, what's called the right front quadrant of a landfalling system, that is the zone to watch. In fact, that right front quadrant is the worst quadrant, period, when it comes to hurricanes. That is a quadrant where you're going to see the strongest winds. That's the quadrant where you're going to see heaviest rain, most likely. And that's definitely the quadrant where you're going to see the highest storm surge and the highest risk for tornadoes. And the waves and rip currents. Yeah, this is one of the most overlooked hazards. Now, let me give you some stats. Hurricanes are huge, right? So even if we get a hurricane, you kind of look at this map up here, even if we get a hurricane well offshore of the East Coast, and let's say this hurricane track like that, you can still get a huge wave field all the way up the coast. We've seen fatalities in Florida and in Maine from the same hurricane as the swell field propagates so far, sometimes as much as 1,000 miles away from the storm center. Hurricane Lorenzo in 2019 tracked over the eastern Atlantic, but still killed 8 people along the US East Coast due to rip currents. Hurricane Delta, we were way into the Greek alphabet that year, caused fatalities in Florida, even though it officially made landfall in Louisiana. So rip currents, high waves are just a huge factor, a huge, huge factor. All right, I want to briefly end with some of our challenges. Now, I already mentioned this one, our messaging challenge. The media is often just way too fixated on the category, but not on the hazards. And we've had plenty of fatalities from, let's say, category 1s. You can get category 1s in New England. We've had 175 direct deaths from category 1 hurricanes in the last 11 years. And they've caused $105 billion in damage. 2 have affected New England, Irene in 2011, Sandy in 2012. And unfortunately, we know there'll be more. And it's been busy, like I mentioned. There have been more category 4 and 5 landfalls in the US since 2017 than we had from 1963 to 2016. Check out these statistics. In the last 4 or 5 years, the US has seen a total damage of almost $483 billion just from hurricanes, not weather hazards, just hurricanes. There's been 18 storms that have caused at least $1 billion in damage, and 7 storms have caused at least $10 billion in damage. Now, as I mentioned, we've had some successes. Some of the successes I'll talk about is, we've reduced the amount of storm surge fatalities. In Sandy, we had a whole bunch of fatalities in 2012. The storms of late, we've had a lot less fatalities, which is awesome. We're really happy. Only 3 fatalities have occurred directly to storm surge in the last 2 hurricane seasons, despite 8 landfalling systems. But we still have a problem. I want to communicate the problem, and I want to end here. Our problem has been the indirect fatalities lately. Take a look at this chart. For the indirect fatalities, the biggest problem is amongst the older age community. 58% of the indirect fatalities have occurred in people greater than the age of 60. The number one factor has been heart attacks, as you can see here, but there have been many other factors as well. And I'll talk about those in just a minute. Now, Ida was a big deal last year. Now, take a look at this. We've had 55 direct fatalities from Ida. This is Ida's track. It officially made landfall in Louisiana as a Category 4 hurricane, but we only lost 4 people in Louisiana. And we lost 2 in Mississippi nearby. But 49 people perished in the mid-Atlantic and into southwestern New England? What gives? Again, the freshwater flooding. We had a situation where there was just tremendous flooding where those red dots are here in the Northeast and the mid-Atlantic. We had a nearby front move, and the storm moved right along this track, flooding areas there. And you might remember pictures from New York City with subways flooded out. And they were nowhere near the strongest winds. That's just the reality. And the indirect fatalities. I want to end with this statistic here. In the last 4 years, we've lost more people during hurricane events to carbon monoxide poisoning after a storm than we have during the storm due to storm surge. Improper use of using your generator, improper use of really kind of being, that's my alarm to stop, improper use of putting generators in your home, carbon monoxide poisoning. So the Hurricane Center is really trying to take a mission this year to focus on these indirect fatalities, to get people to know what to do and not look at hurricanes as just an event of when the weather's bad. But we don't want to lose people before, during the evacuation period, during, or after, when the power's gone. So guys, I'm going to end here. I know it's a bit of a dark note, and I apologize about that. But if there's any comments or questions, I really would love to hear it.
John, thank you so much. That is excellent. I know, obviously, you can go a lot of different directions in talking about many aspects of hurricanes. But at any rate, that certainly helps start the conversation for sure. And we already have a lot of great questions here. Oh, John, great. I will ask that you stop sharing your screen just for a moment, just so I don't have to stare at myself once again, as much as...
You got it. Let me, did I stop? Did it stop? I don't know.
It did. Yeah, I think it stopped sharing your slides there for a second. And that's okay, but feel free to reference back to your slides at any point. And for those of you joining, so John's generous enough to keep the time he wanted to share to make sure that we can get to some time for questions. There are already a number of great questions through Zoom. So for those of you who are interested in asking some more, don't forget to use the Q&A button that you find at your toolbar at the bottom of your screen there on Zoom. And we'll just dive right into it and see how many we can get to here. And John, this is a question actually I had was curious about as well, but Keith asked this question. Asking, hey, as it relates to forecast, how much does the National Hurricane Center rely on data gathered from the hurricane hunters and their aircraft and maybe even other aircraft or UAV? And so, yeah, I mean, I know you guys have a relationship. I know you use their data quite a bit, but what's that relationship like?
The relationship's great. So yeah, first I'll start with saying there's 2 sets of hurricane hunters. So there's the Air Force hurricane hunters and the Noaa hurricane hunters. We use all of their data. In fact, here's how it works in a nutshell. So we have a dedicated unit at the Hurricane Center that talks to the hurricane hunters. It's only 2 or 3 people. And every morning they'll come out and say, hey, do we need to fly today? And the answer from the forecaster will say yes or no. And if we don't need to fly, then the sort of communication's over for the day. If we do need to fly, it's saying, okay, where, when, where do you want us to put our instruments? So when they're in the air, we have direct line of communication with the pilots and meteorologists. And once they turn on their instrumentation, we can see their data in just seconds of lag. So they collect data at their altitude, which varies depending upon the storm strength. They collect data from their radars. They collect data from instruments called dropsondes, which they actually release from the aircraft down to the ocean surface. They got little parachutes, so they fall slowly. And they collect data from really cool newer instrumentation that uses physics and math to figure out what the wind speeds are down at the ground, which is really the newest technology. So yeah, we communicate with them, we use their data. In fact, their data even goes into the American models to help get a better initial point. So their data helps us tremendously, easily the best data we have access to at the Hurricane Center.
And so, John, are you getting on the phone and making that call and saying, hey, we really need you to take another flight out there? Boy, we'd really like another, measurement? Or how does that, I mean, without getting too technical, how does that work?
Yeah, so like the first sort of layer of planning is done in the morning, but during the mission, they'll say, hey, where do you want us to be? We're not finding a lot of wind. So I can actually say, check this point, go out that far, maybe turn around, go this way. So there's an open dialogue all the time. So if you ever see them make a U-turn, it's just because the forecaster said, hey, no, go check this out. They're basically just on a hunt for us. So it's really neat. And by the way, I got to go on one joyride with them. I'll never do it again. I mean, I was so sick. Now, I did get to fly into a Category 5 over the middle of the ocean, but at the Gulf of Mexico, but I don't know how they do it. I mean, it is a rough ride. Let's just say that.
Yeah, well, we've been fortunate enough to host a couple on the mountain, and clearly adrenaline junkies. I guess that's probably why they came up to Mount Washington too. Awesome.
Obviously, right.
Well, so John, you kind of referenced a little bit some of the technology. I mean, certainly in your presentation, and there's a great follow-up question here from Kenneth as well, who's, hey, we got some self-professed weather nerds here, and wondering if you can be maybe a little more specific about some of the science or maybe even some of the other technology or observations that have really helped improve prediction.
Yeah. So on the data side, satellites have changed a lot. So since 2016, we had these new satellites go up from Noaa and NASA, GOES 16, GOES 17. And because at the Hurricane Center, we're mostly fixated on the oceans, satellites are huge friends. In fact, we consider satellites our eyes. I don't know how people in my job did their jobs before satellites. I mean, if you don't know a lot about the satellites today, for some of the audience, there's 16 different channels. You get a new image up to every minute, even better than every minute in some occasions. And I don't even know how to use all the channels. I mean, in the past, we had like 3 or 4 or 5 channels. So we're seeing so much more information. So satellites are far and away our #1 tool on a day-to-day basis. I still say the Hurricane Hunter data is the best data. We just don't have it every day. On the modeling side, the technology's been tremendous. So the global models, they're not just for hurricanes. I mean, they're general weather forecasting. They've improved a lot. So in particular, the 2 best models are the American GFS and the European Center Global Model. The United Kingdom Global Model is kind of a 3rd place model, with the US Navy really lagging behind and the Canadian Global Model kind of lagging behind. And they help us a lot for track prediction. And to kind of give you a sense, those models give us about 70% of skill over climatology. And I know that's a bit technical, but the way to look at it is if I just say, I'm just going to try to pick the best model, I'll get 70% of skill, which is great, right? That's really good. Now, the Hurricane Center usually can beat those individual models by taking consensus approaches and using our brains to try to outperform them. And we do outperform them every single year. But where the models haven't improved as much is with intensity forecasting. And I know I said this a little. So let's say I repeat the same exercise for the intensity models. The GFS, the American Global Model, has only 10% of skill over climatology for intensity forecasting. The European Center has 0 skill. So we can't use those. Those are not going to help us. So the advent of the HWRF and the HMON, these are American hurricane-specific models, give us about 30 to 40% of skill. So that's kind of where we're at. Now we can get 40 to 50% and kind of beat the models a little bit, but we're still lagging behind. And then lastly, for predicting size, which is important, the models only give us about 10 to 20% of skill over Climo. So I often tell like younger people than me, students that are graduating college and graduate school, if you want to do hurricane research, don't bother with looking at the track because we've got a long way, but please dig into the structure, the size, the intensity. There's still a lot of room for improvement there.
And so, John, that kind of makes me wonder a little bit. I mean, so to the best of your knowledge, I mean, what's missing from some of those models, which I guess part of that, I'm guessing, is probably what data are you missing, or what is the quality of the data perhaps that you're missing? I mean, I don't know, if you could have it your way, I mean, would you just put weather stations everywhere, or what might be, what are you looking for there for improvements?
Such a good thing. So it's such a good question. So for like getting the structure right, we really need, like you said, true data. Like most of the time we're relying just on satellites. So satellites are essentially pictures, but they're not hard data. So we don't really know where the strong winds are unless the hurricane hunters are out there. So when the hurricane hunters are out there, then that data goes into the models and all of a sudden they're a lot better, right? But we can't, it's too expensive to have them out there. Now, NASA has developed a drone. I mean, we talked about, I think this was mentioned. So those can fly higher, stay up longer, and drop instruments all on their own, but it's still expensive. I mean, we're not at a place where we can do that every single time there's a storm. We have to be selective. So the only way to fix this is data. The only way to fix those problems is data, truthfully. The models can only take you so far, but if they don't know what's happening right now, they can't predict what's going to happen in the future. That's just the reality.
Well, the Mount Washington likes to sell the value of our data and the high quality of it and all that, and we get a nice model in return that helps our forecasters, ultimately make great predictions because they're collecting good data to begin with. But yeah, certainly they would love more and higher quality for sure.
Right.
So I got a question here. So changing gears a little bit from weather to climate, Ed asks the question that I'm sure you get quite a bit, which is, how does climate change factor into the influence on hurricanes? Track, severity, frequency, any of that, it impacts those sorts of things. What's the sort of big picture answer to that?
Yeah, this is easily the hottest topic these days is, what does climate change exactly do into these storms? So, I mean, it's still an active area of research, but I will show you where the consensus is today. It doesn't mean the consensus is perfect, and it's certainly not necessarily my stance or the Hurricane Center stance, but this is sort of the tropical meteorology community. So the belief is that climate change, increasing water temperatures, will not necessarily make the seasons busier. And part of the reason they think that is because you still have the other factors like wind shear, moisture, and those are not necessarily changing much. In fact, there's some argument that there could be more wind shear when we raise the water temperatures a little bit. However, the storms will likely get stronger. They'll likely get stronger because you're just giving them more ocean heat. Now, the biggest problem, though, is not necessarily that they'll get stronger. The biggest problem is if we're in a warmer world, essentially the ocean tends to expand. It's just, normal physics. If you have the ocean hotter, then the ocean will rise a bit more, and that makes storm surge worse. And a lot of the cities, the big cities like New York and Miami and New Orleans, are sort of preparing for this by building stronger seawalls and higher seawalls. So that's basically where the consensus is. So we don't think we're going to get like 50 storms a year, but we might have to watch out for the stronger, the storm's getting a little stronger and the impact's getting a little worse, mostly to storm surge. And there's some theory that they could move slower, but it's still kind of an open debate. I love listening to this research. And to be honest with you, I'm learning every single day still. And I love learning about this, and we'll see what the future holds. But that's kind of where the consensus is.
Yeah, that's awesome. I know that obviously there are a lot of different avenues you can go on that, and certainly on a research perspective, there are a lot of different avenues that are being looked into when it comes to the climatology and future of hurricanes. And I'm learning here too, because I got a great question from Ted, who's asking a question sort of made me think of this as well. It was asking, will the predicted slowdown in the AMOC reduce the number or effect of hurricanes that make it to New England? Now, I had to look this up because I am not familiar with that acronym. And for essentially, we're talking about ocean circulation off the Atlantic. What if anything can you speak to, I guess, related to ocean circulation and maybe, you know, multi-decadal sort of changes in frequency and severity of storms, that sort of thing?
That's been an area of research. It's been sort of like, so for a couple of things. So there's definitely, we'll start with the multi-decadal oscillation. That's definitely a factor. So we've gone through decades. Like, for example, the 30s, we didn't really know this, but they were extremely busy. The 30s and the 40s were extremely busy, and into the 50s. And then it went quiet. 60s, 70s, and 80s. These were dead decades. In fact, even in the early 90s, it was pretty quiet. Like the year Hurricane Andrew hit South Florida, there were only 7 storms that year. And that was pretty normal during that time of year. And then we've been in this very active era since the mid 90s. So if you look at charts and you look at history, the multi-decadal oscillation is real. Now, although we know it's real, we don't know when it's going to end. I mean, we don't really know, you know, why even in reality. We just know things have been more favorable for hurricanes. Now, in terms of the AMO, as you brought up, those are factors, they're more regional factors, but they've often been they've been given less weight over the years and less importance. They certainly don't affect storms tracks very much. I mean, the reality is there's sort of, here's the thing, there's a sort of a balance of climate and weather, right? So I'll use Sandy as an example. Sandy took a crazy aclimatological track. I mean, you can repeat that scenario 100 times, you probably won't get a Sandy track again. The problem is that the atmosphere is a fluid. It's moving like crazy. We can have fixed patterns that exist, but where that storm is, when that pattern is shaped up is what matters. So there used to be a lot of credit to say the ridging is in this area, but then the ridging breaks down. And even if it breaks down for a few days and the storm is in that area for a few days, then you might have a hit or you might have a miss. So there's generally less influence on those smaller scale cycles like AMO.
Interesting. Yeah, fascinating. I mean, I'm looking at a number of research papers here and certainly looking into that and finding, you know, some levels of relationship there. But I mean, I guess what I'm curious about as well, I've seen now a few questions, including one from Barbara. Barbara spent a lot of time out on the Cape, and you know, her and her family, she said they were kind of rooting for storms, maybe to see something come maybe on shore and all that. But I mean, I guess the question that Barbara's getting at, and some other folks as well, is, you know, what are the major factors, particularly for New England, that ultimately are at play that I'm sure are very similar to, you know, what you're looking at throughout the Southeast and the Gulf of Mexico? But what are those major factors that are typically, you know, controlling what's happening to storms in New England?
Yeah, so New England's an interesting place because we don't expect the storm to be strengthening on its approach to New England. I mean, usually you're passing the north wall of the Gulf Stream by there, and the storms are usually weakening. So what are the factors? So let's say tide. Tide is a huge factor in New England because the difference between low tide and high tide is dramatic. So if a storm makes landfall at high tide, the chances of it bringing water to locations that are normally dry is much greater. So timing is huge in New England, way more than Florida, for example. Florida, the tide cycle is a difference of like a foot, and it's not going to make a huge difference, but that's certainly not the case in coastal New England. So timing is a big factor. In New England, we're dealing with very large systems. Just about every storm that gets to New England gets huge. And the reason that is just because of just two things. Well, one, it's Coriolis, and the storms tend to expand and move faster up there. But the other factor is they're old. They're old storms by there. They just are. It's sort of their last stop by the time they get to New England. And storms have this really interesting phenomena that most times they start small to medium, and they just grow throughout their life cycle. And by the time they get to New England, they're usually much larger than average. So you could be dealing with, you know, a lot more impacts from rain and surge and tornadoes. So the reality is I wouldn't expect to see a major hurricane in New England, but you still get the same sort of package of hazards that you get in other places. And you're dealing with a community that's a little less experienced to hurricanes, which makes the sort of communication and sort of the decision-making a little more challenging.
Well, I did note, and I'll just confess, it was a matter of coincidence that this week, I believe, for National Weather Service is Hurricane Preparedness Week, and certainly there was some great messages coming out of our local forecast office because, hey, you know, certainly in New England, a place that still needs to stay on its toes because, like you said, may not be expecting it, and when they come along, I mean, the impacts can be very similar.
Right, absolutely.
All right. Well, I'll leave it with just one more very interesting question that I would love to know if you know anything about here, and we'll certainly wrap up for the evening, and we'll certainly pass along any other questions that folks come up with here. But Tyler asks, has there been a lot of discussion at NHC about future utilization of the aquatic sail drone that went through Hurricane Sam last year? So yeah, I was thinking, for drones, we're thinking flying through things, but certainly there's quite a bit of unmanned other types of drones on the water and below the surface.
Yeah, Tyler, good question. That was one of the coolest things ever. I got to be honest, because if you didn't see that video, you might be able to access it in some places. So that drone was in just the right place. The storm went essentially right over it. It didn't quite catch the worst conditions, we think, but it was still very close to the eye wall. And well, we'd love to have those. We'd love to have more of those. I mean, that certainly comes down to just the same cost issue, and Tyler, there's nothing better than having hard data, period. And to have hard data with a visual is just an amazing thing for a forecaster and for a weather enthusiast, and really just to learn about what's occurring. It just comes down to financial cost. We're in a situation where the ocean's huge and we just can't know where to put these things. And NASA's developed these amazing drones, but they're costly. So great question. Maybe in a couple of decades we'll have more of these things, but I think this is just more experimental and interesting right now than truly beneficial to NHC.
Interesting, very interesting. We'll have to keep our eyes open for those sail drones. And now you got me curious. I'll have to take a look at some of that info.
Definitely check it out. Yep.
Well, John, thank you so much for taking the time tonight to present, to share your knowledge with everyone, for obviously what you do for our country, but also, globally what you add to science and for helping keep people safe in your role. And thanks again for your program this evening, and for all of you for joining. If there are any questions that came up that we didn't get to tonight, feel free. You can reach out to me directly at education@mountwashington.org. Happy to send along any questions to John now that we got his ear here. If you enjoyed tonight's free program, certainly would encourage you to make a donation to Mount Washington Observatory over at mountwashington.org. You can find the donate button in the upper right-hand corner there. Don't forget that a donation in any amount also makes you a member of our organization. If you have thoughts about tonight's program or suggestions for future programs, please, we'd appreciate you taking some time to fill out the Google Form survey that will follow up after this program. And don't forget to join us for next month's program on Tuesday, August 16th, when our summit interns, Naomi Lubkin and Henry Moskowitz, will be providing some updates on 2 newly launched research projects at Mount Washington Observatory. So don't forget to register for those programs, for catching any of the programs you might have missed over at mountwashington.org/SITM. Thank you so much again, John. Really appreciate it. Thanks to all of you for joining tonight, and we'll see you again soon. Have a good night.